Today we're going to continue our conversation on percents with the percent proportion. What the percent proportion allows us to do is it allows us to solve percent problems. So we get to solve for percents of numbers, we get to find out what numbers, parts of them, what percents they represent, and so on and so forth. So today we're going to be using the percent proportion to find the percents, the parts, and the wholes of a number. So like for example, anytime you get a test and the teacher marks it 14 out of 17 and you're thinking to yourself, what is my percent grade? What is my correlating letter grade? Well, the percent proportion would help you solve for your actual percent letter grade. So let's get right into this. The percent proportion, as we teach it and as we know it, is going to be the part of a number out of the whole number is going to equal to the percent out of 100 that that number is equal to. So for example, if you pay $15 for a shirt that is worth $20, 15 is the part, the whole is 20, and that 15 out of 20 tells you, that 15 out of 20 tells you what percent of the actual price you paid. Okay, so we use the percent proportion to say that a ratio of a number to whatever whole it was taken out of is equal to the percent of the whole that it originally was. Okay, so for example, if I have an orange and I eat 1/4 of it, I know that that 1/4 of that orange is equal to 25% of that orange. So that 25%, we know that 25 over 100 reduces to 1/4, or in solving proportions, if I were to multiply 25 times 4 is equal to 100, 1 times 100 is equal to 100, so my cross products are equivalent, the proportion works. Now, these three proportions down here, while they are very helpful, a basic understanding of the percent proportion is all you really need to actually set up any problem. This, though, down here will help you if you're looking at a problem and you're not quite sure how to set it up. This is a good clue into, well, if I have this and I have that and I always have that 100 right there, then this is the piece that must be the variable. So if you're looking for the percent when you're solving a problem, that means when you've read the problem, the part and the whole were given, and the percent was the only thing that you didn't know. If you're looking for the part in a problem, that means when you read the problem, you found the percent and you found the whole, but you did not know what the part was. That 100 is always going to be there, and it's always going to stay the same because you always put the percent out of 100. Now, if you read a problem and you're trying to find the whole, that means that when you read the problem, you were able to find the part and the percent, and the piece that you didn't know was the whole. Okay? Again, a few examples of this before we actually solve some examples. An example of a problem where you would be looking for the percent would say, what percent of 5 is 4? I know that 4 is the part and 5 is the whole because I'm looking for the percent that 4 is, so that makes 4 the part. Finding the part might read like, what number is 80% of 5? 80% of 5, that means I'm looking for a part of 5. I don't know the part, so then the proportion I would set up is right here. Find the whole might read like 4 is 80% of what number? 80% of what number? That tells me that I don't know the whole, but I do know the part and I do know the percent. So in a percent proportion, one ratio or fraction compares part of a quantity to the whole quantity. The other ratio is the equivalent percent written as a fraction with a denominator of 100. So we always know a percent is out of 100, so that 100 is always the denominator of the percent ratio. So 4 out of 5 is equal to 80%. 4 is the part, 5 is the whole, 80 is the percent, 100 is what the percent is always out of. Let's do some examples. Alright, so example 1. What number is 30% of 150? Since I'm looking for a number that is a percent of another number, I know I'm looking for the part. So again, my percent ratio, or my percent proportion rather, is that the part out of the whole is equal to the percent out of 100. Now you'll notice that I'll write this down for the first couple of examples. I would recommend writing it down until you have it memorized. Because there's no reason to have to look back to this. This is something that's really common in your life. So percents are going to be very important. It's very important to know how to calculate them. So we know that we don't know the part, so let's call that x. But we do know the whole. and we do know the percent, and we always know that the percent is out of 100. Now, if you've forgotten how to solve proportions, I'm going to solve this proportion for you, but you can always go back to my first set of videos, and there is a video on proportions. I can link that video in the helpful links section of my website, and you can always go back or ask me for help in finding it. So, to solve a proportion, we know the cross products have to be equal, so I'm going to cross multiply. 30 times 150, that's going to be 4,500. 100 multiplied by x, that's going to be 100x. I now have a one-step equation that I can solve to get the answer to my problem. So to isolate my variable, it's being multiplied by 100, so to undo that, I'm going to divide by 100 on each side. I get that 45 is equal to x. So when I answer the question, what number is 30% of 45? That number is, of 150, that's 45. Okay, let's try another example. Example 2. What percent of 24 is 18? So I look at this problem and right away I know that I am missing the percent, so I just need to figure out what is the part and what is the whole. So again, the percent ratio is part, the percent proportion is part over whole is equal to the percent out of 100. In this case, I know I'm missing the percent, so that's what my variable will stand for, and I know that it's out of 100. So in the problem it says what percent of 24 is 18. Now sometimes the part will be larger than the whole if we're talking about markups and things like that, but in this case the part is the smaller one. It's going to be 18 because we're actually asking what part of 24 is 18 because the percent is always the part. Okay? So again, it's a proportion that we have to solve. So I'm going to cross multiply. I get 24x is equal to 1800. To isolate my variable, which is being multiplied by 24, I'm going to divide by 24 on each side. And my result will be that x is equal to 75. So in answering the question, what percent of 24 is 18? That means that 18 is 75% of 24. So if you were to take a quiz and get an 18 out of 24, you know that your score is actually a 75%. Let's try a couple more examples. Example 3. 12 is 80% of what number? So again, we know that part over whole should equal percent out of 100. In this case, I do know the percent. It's 80. Now let's figure out if we know the part or the whole. 12 is 80% of what number? So 12 is the part of what number? So that means that 12 is the part, and I don't know the whole. Again, since I have a proportion, and you can work ahead of me, you can pause and solve it here and see if your answer comes out the same as mine. I'm going to cross multiply. I'm going to get 80x equals 1200. To isolate my variable, I'm going to divide by 80 on each side. I will get that x is equal to 15. So in answering the question, 12 is 80% of what number? Well, that number is 15. So again, if you were to take a quiz that was 15 problems long and you got 12 of them correct, you would have an 80% on that quiz. Okay, so our last example before we get to the problem of the day. Sally read the nutrition facts on a box of her favorite cereal. Each cup of the cereal provides 7% of the recommended daily value of potassium. If a cup of the cereal contains 260 milligrams of potassium, what is the recommended daily value of potassium? Round your answer to the nearest whole number. So as I was reading the problem, I was just underlining the important information that would help me solve it. 1 cup is the equivalent of 7% and is also equal to 260 milligrams. So I know when I'm setting up my proportion, part over whole, I have my percent. Part over whole equals the percent over 100. Well, I know my percent is 7 out of 100. 260 milligrams are contained in 1 cup. they tell us that 1 cup contains 7% of what's needed. So 1 cup only contains a part of what's actually needed in the day. So that 260 is going to correlate to the part. I don't know how much potassium I need in a day. I actually need to solve for that. So I'm going to cross multiply. I'm going to get 7x, going down this way, is equal to 26,000. I'm going to isolate my variable, divide by 7 on each side, and I will have x is equal to, now I'm going to do this on the calculator just so that you can see what decimal I get and how I round it to the nearest whole number. So 26,000 divided by 7, I'm going to get 3,714.2857, and so on and so forth. So I'm looking right here at this 2. Since it's less than 2, I'm going to round down, and my final answer is going to be 3,714 milligrams of potassium needed in a day. All right, let's get into that problem of the day. So tomorrow the first thing that we'll look at in class is if I want to know what 47% of 70 is and 39% of 120 is, how would I calculate that using the proportion method? So this is worded slightly differently than the problems of the problems of this video. But if we look at this and think of it, 47% of 70, and then I won't help you with the second one here, that means that I am looking for a part of 70. So I know my 47 is out of 100, and I'm looking for a part of 70. Okay? You're going to kind of use the same method for number 2. So good luck, and I will see you tomorrow.